Hello, I am Rochelle Angela Valdez, and I am going to discuss about minor and miscellaneous blood groups. To start, here is the outline of my discussion. You will know the information about the following blood groups: Cheeto Rogers, Knox, Indian, John Milton Hayton, York, Augustine, and Langerais.
Why do we study other blood group system? In addition to the antigens of ABO and Rh blood group systems, more than 200 unique antigens have been documented on red cells. At the present time, the International Society of Blood Transfusion has defined 30 blood group systems. In traditional terms, the blood group antigen has been considered the target of a red cell alloantibody or autoantibody. The antigen-antibody complex may trigger a process leading to the immune-mediated destruction of red cells. Primary efforts in the blood bank have revolved around problem resolution relating to this pathophysiologic road. In addition to this pathophysiologic roles, the molecular cloning of blood group genes has provided insights into the primary functional roles of this blood group's antigen. Most recent studies have linked blood group systems with unique roles in the following physiologic functions related to red cell membranes. First, molecules that function in transporting water-soluble molecules across the lipid bilayer for intake of nutrients and excretion of waste products. Second, molecules that function in the complement pathway. Third, molecules that play a role in the ability of cells to adhere to other cells. Fourth, molecules that function as structural proteins to maintain red cell shape and mechanical deformability. Lastly, molecules with suggested enzyme activities.
In addition to serving these physiologic functions, red cell antigens can function as microbial receptors for infection by microorganisms. An overview of the relationships of the blood group systems and their unique functional roles is presented, and we will just focus on the specific blood group systems for our discussion. Miscellaneous blood group systems are less commonly encountered in routine transfusion medicine. In many of these systems, the clinical significance of the antibodies associated with the system is unknown or not well documented because of the scarcity of examples. Antibodies to the antigens in these systems are infrequent because most are of either high frequency or low frequency, and others are of low immunogenicity. And the table presented summarizes these systems or collections. Low frequency antigens that do not belong to a collection or system are not included. The use of molecular techniques has added to the knowledge of genetics and antigen products, and in some instances has altered their classification. And again, we will just focus on the specific blood group systems for our discussion.
Here is the diagram that depicts the membrane components that are known to carry blood group antigens. Some antigens are carbohydrates attached to lipids or to proteins. Some are protein, and some require both protein and carbohydrates. Although the blood group antigens do not themselves have a function, the molecules on which they are carried do. The functions of proteins carrying blood group antigens has been determined through observation of the morphology of RBCs that lack the protein, direct experimentation, or comparison of the predicted protein sequence with protein databases to identify similar proteins whose function is known, even if in other tissues or organisms. First blood group to be discussed is Cheeto Rogers, ISPT number 17. Chido and Rogers antigens are located on the fourth component of complement, also known as C4, which becomes bound to RBCs from the plasma. The Chido-Rogers blood group system contains 10 antigens, including 2 pairs of antithetical antigens and 3 conformational antigens. The latter require co-expression of 2 spatially distinct Chido-Rogers antigens that together generate a third conformational antigen. Most Chido-Rogers antigens are high-incidence antigens. Similar to Lewis blood group antigens, Chido-Rogers antigens are of plasma origin and are passively adsorbed onto RBC membranes. Its antigens are weakly expressed on cord RBCs and some glycophorin A deficient RBCs. Chido-Rogers antigens are antigenic determinants on the C4d fragment of the C4 complement molecule. C4 is the product of 2 highly homologous genes, C4a and C4b, on chromosome 6p213 near the HLA locus.
Antibodies against Chido-Rogers antigens do not cause hemolytic transfusion reactions or hemolytic disease of the fetus and newborn. Rare reports have described anaphylaxis following transfusion of plasma and platelets. Anti-Chido-Rogers antibodies are of IgG isotype and are usually detected with AHG. Antibody reactivity can be enhanced by incubating RBCs in a low ionic sucrose solution. And antibody reactivity can be inhibited by plasma or by treatment of RBCs with proteases. Antibodies in the Chido-Rogers system do not activate complement and are considered benign and nebulous. There can be considerable variations in the reaction strength obtained with different RBC samples. Although these antibodies do not generally cause transfusion reactions, they have caused anaphylactic reactions. The antibodies have not caused hemolytic disease of the newborn. Anti-Chido and anti-Rogers are neutralized in the test tube or in the circulation by plasma from CH positive or Chido positive and Rogers positive persons respectively. C4a binds preferentially to proteins and C4b to carbohydrates. C4b binds more effectively to the RBC surface through sialic acid and thus is more effective at promoting hemolysis. A given single amino acid substitution converts the functional activity of C4b to C4a, whereas the other amino acid affects hemolytic activity and IgG binding. Inherited low levels of C4 may be a predisposing factor for diseases such as insulin-dependent diabetes and autoimmune chronic active hepatitis. Specific C4 allotypes and null genes have been associated with numerous autoimmune disorders.
Second blood group system is NOPS, ISBT number 22. The NOPS blood group contains 10 to 12 antigens, including 6 antithetical antigens. Several NOPS antigens are racially segregated. NOPS antigens are present on adult and cord RBCs, neutrophils, B lymphocytes, and dendritic cells. NOPS antigens are resistant to proteases but are weakened by sulfhydryl-reducing agents. The NOPS antigens are weakly expressed on RBCs of newborns, RBCs with dominant Lutheran phenotype, and RBCs of patients with autoimmune diseases. CR1 is present on B cells. A subset of T cells, monocytes, macrophages, neutrophils, eosinophils, glomerular podocytes, and splenic follicular dendritic cells. NOPS can vary in strength between individuals, with approximately 1% of donors showing extremely weak NOPS expression. Furthermore, NOPs reside on complement receptor 1, a 220 kilodalton glycoprotein. The extracellular domain consists of 30 SCRs arranged into 4 long homologous regions that are capable of binding C4b and C3b. The molecule also possesses 6 to 8 N-glycosylation sites. NOPs antibodies are clinically insignificant. NOPs incompatible RBCs have normal survival following transfusion, and NOPs antibodies are of IgG isotype arising from immune stimulation and are usually detected only with AHG. Historically classified as an HTLA antibody, NOPs antibodies are notoriously difficult to work with because of their low avidity, biological variations in NOPs expression, antigen degradation, and the common presence of additional alloantibody specificities. Antibodies in the NOPs system are reactive on the indirect antiglobulin test, and they do not bind complement. The antibodies do not cause transfusion reactions or hemolytic disease of newborn. Once identified, they can be ignored for clinical purposes. Identification may be complicated by the fluctuation of antigen expression on RBC. Third blood group system is Indian, ISBT number 23. The Indian antigen reported in 1973 is on RBCs from 4% of Indians from Mumbai. This blood group system was named because of its association with India. INA and INB, the antigens of the Indian system, are carried on CD44. The CD44 gene is located at chromosome 11p13 and consists of at least 19 exons, 10 of which are variably spliced. The CD44 glycoprotein passes through the RBC membrane once, and the extracellular N-terminus has 6 cysteine residues, 6 N-glycan sites, 4 chondroitin sulfate sites, and potential sites for O-glycans. The INA and INB polymorphism is due to Pro46ARG on CD44. INB is common antigen, and INA is rare in white persons but has an incidence of 4% in Indians, 10% in Iranians, and nearly 12% in Arabs. CD44 is expressed on neutrophils, lymphocytes, monocytes, brain, breast, colon, epithelium, gastric tissue, heart, kidney, liver, lung, placenta, skin, spleen, thymus, and fibroblast. The antigens are sensitive to treatment of RBCs by proteases and diethyothiol, but resistant to treatment with sialidase and acid. Indian antigens are weakly expressed on gourd RBCs as well as on RBCs from people with the dominant Lutheran phenotype and from pregnant women. Antibodies in the Indian system are usually IgG and reactive on the IAT, and they do not bind complement. Some antibodies may directly agglutinate RBCs, but the reactivity is greatly enhanced by the IAT. These antibodies have caused decreased RBC survival and a positive that result in the neonate but not HDN. A severe delayed hemolytic transfusion reaction due to anti-INB has been reported. Joint fluid from patients with inflammatory synovitis has higher than normal levels of soluble CD44. The serum CD44 value is elevated in some patients with lymphoma. CD44 has a diverse range of biologic functions involving cell-cell and cell matrix interactions in cells other than RBCs. It is an adhesion molecule in lymphocytes, monocytes, and some tumor cells. CD44 binds to hyaluronate and other components of the extracellular matrix and is also involved in immune stimulation as well as signaling between cells. Fourth blood group system is John Milton Hagen, ISBT number 26. This system contains 6 high-incidence antigens and can vary in strength between individuals. In addition to RBCs, JMH is found on lymphocytes, activated macrophages, thymus, brain, respiratory epithelium, placenta, testes, and spleen. JMH weak, JMH variant, and JMH negative has been described. An acquired JMH weak to negative phenotype can occur in the elderly, accompanied by the occurrence of JMH and autoantibodies. 5 distinct autosomal recessive JMH variants have been described as the result of single missense mutations. At least one example of an autosomal dominant JMH negative phenotype has been described. JMH is carried on CD108 or CD108, a semaphorin family glycoprotein. The molecule contains an RGD sequence essential for promoting axonal growth. The molecule is anchored in the cell membrane by a GPI tail and is absent on PNH3 RBCs. The molecule contains 19 cysteine residues and is sensitive to sulfhydryl reducing reagents. Anti-JMH antibodies do not cause hemolytic transfusion reactions or HTFN, although shortened RBC survival has been documented in some patients. The latter may reflect true alloantibodies in JMH variant individuals. The antibodies are of IgG isotype and can be naturally occurring. The JMH antigen is sensitive to proteases and DTT. An assay for detection of anti-JMH antibodies are recently developed for gel using immobilized recombinant SEMA7A on polycystin beads. Semaphorin proteins are implicated in cell signaling. In hematopoietic cells, SEMA7A can modulate cellular immunity via effects on T cells, monocytes, and natural killer cells. SEMA7A inhibits NK cell proliferation and is a negative regulator of T cell activation. Conversely, SEMA7A stimulates chemotaxis, secretion of inflammatory cytokines, and dendritic cell maturation in monocytes. Next blood group systems are rare: York, Augustine, and Langerais.
Antigens of the NOBS blood group system are presented on complement component 3b and 4b, receptor 1 CR1 and CD35, which is a transmembrane glycoprotein encoded by the CR1 gene. 8 of the 9 known antigens of this system are linked to polymorphisms in exon 29. The molecular background of one antigen, York, has not yet been described. There are 6 antigen specificities presented on the table. The hypervalence antigen August was first identified in 1967, but it was not until 2015 that August became AUG1 of a new blood group system, Augustine. The new system was established after the identification of the gene encoding Augustine and the recognition of a null phenotype in an Augustine negative patient with an antibody reactive with Augustine red blood cells. The Augustine negative phenotype is very rare, and with the exception of the one family with null phenotype, has only been found in individuals of African origin. Anti-Augustine has been implicated in mediate and delayed hemolytic transfusion reactions, but not in the severe hemolytic disease of the fetus and newborn. The Augustine gene is SLC29A1, which encodes the equilibrative nucleoside transporter ENT1. Absence of ENT1 in that family may be associated with pseudogout and abnormal bone calcification. A number sign is used with this entry because the Langere's blood group phenotype is caused by homozygous or compound heterozygous mutation in the ABCB6 gene on chromosome 2q36. Individuals with Langere's blood group lack the Langere's antigen on their red blood cells. These individuals may have anti-LAN antibodies in their serum, which can cause transfusion reactions or hemolytic disease of the fetus and newborn. The Langere's blood group is only significant in transfusion settings or during pregnancy. Otherwise, Langere's individuals have no clinical features. Presented in this discussion the clinical significance of some alloantibodies to blood group antigens. And here are the characteristics of some blood group alloantibodies. A quick overview about genetically discrete blood group system is also presented. What time is it? It's quiz time! Now I will give you items or questions to be answered for an assessment if you really learned on our discussion. What blood group system wherein it functions in biological receptors and complement pathway molecules? The answer is Knopp's blood group system. In Cheeto-Rogers blood group system function, where do C4a and C4b bind? The answer is C4a binds to proteins and C4b binds to carbohydrates. What blood group system wherein its antibodies are usually IgG, reactive on the IAT, do not bind complement, may directly agglutinate RBCs but their reactivity is greatly enhanced by the IAT, decreased RBC survival, and a positive dot result in a neonate but not HTN? The answer is Indian blood group system. Okay, then that's all for our discussion. Thank you for listening. For my references, I used Blood Banking and Transfusion Medicine Basic Principles and Practice 2nd edition book, Henry's Clinical Diagnosis and Management by Laboratory Methods 22nd edition book, and I also got some information online in PubMed. That's all. Thank you for listening. God bless and keep safe.